Hey guys, welcome to day 58. Today we're taking a look at this is kind of our last thing before our next test. We're going to take a look at what I like to call rate in, rate out problems. We've looked at things with rate in and things with rate out. We haven't looked at any with both a rate in and a rate out. Okay, so go ahead and pause the video and copy down this prompt into your notes, and then unpause it and we'll talk about what it means. Okay, so the first thing we know here is it says water fills a tank at a rate of R of t equals 6 plus 4 sine of t squared over 15. Okay, so that ugly equation there is the rate at which water fills a tank. Now, if it's water filling a tank, do you think that would be considered the rate in or the rate out? Well, in this context, this is definitely the rate in. What I want you to do when you see these kind of problems, okay, we'll look at a lot of them. When you see these kind of problems, identify what is your rate in. By the way, these are usually almost always calculator problems. This is an example of a calculator problem. So R of t then is my rate in. So my rate in is R of t. Okay. So that's the rate at which water fills a tank. Now, what we know about this from before, right, is if we integrate that rate, like let's say we integrate that rate from 0 to 8, right, as we can see our time, that's the whole time that this rate is going on. Integrating that rate will give us the amount of water added to the tank in those 0 to 8 hours, right? We saw that in our last standard. Okay, so if you integrate a rate, you get that amount, and that amount would be in liters, right? Since R of t is measured in liters per hour, right? That would be the integral from 0 to 8 of R of t dt would be the total amount of liters added to the tank between those hours of 0 and 8. But what we have here is it says after 2 hours, okay? So not right at the beginning. Sometimes there'll be a rate in and a rate out where they both start at 0, but sometimes they won't. After 2 hours, a plug is removed from the tank and the tank drains at a constant rate of 5 liters per hour. So that 5 liters per hour, if it's water draining from the tank, that would be called our rate out. Well, sometimes your rate out will be like another function, like what looks like R of t, right? So maybe they'll call it, for draining, they'll call it D of t or something, okay? But our rate out here is just a constant number of 5 liters per hour. Again, it's a rate, so it should have rate-like units. Notice the time there. It only goes from 2 to 8 hours. You need to pay really close attention to the fact that that interval is different than the R, right? The rate out interval is different than the rate out. So take a look. Be very aware of that. Okay? So we have a rate in, water filling a tank. We have a rate out, water draining from the tank. Okay? The third thing that we have to pay attention to is our initial condition. It says at t equals 0, the tank has 60 liters of water in it. That would be our initial condition. So when you get these problems, you're going to want to annotate them. We need to pay attention to the rate in, we need to pay attention to the rate out, and we need to pay attention to the initial condition. Sometimes the initial condition will be the tank is empty at the beginning, right? Well, that's still an initial condition. It's just an initial condition of 0. Okay, so let's think about what we know so far. Okay, what we know so far is integrating R of t, what we know is the integral from 0 to t of r of t dt, right, to whatever time we want, right? If we wanted 0 to 2, that'd be in the first 2 hours. If we wanted 0 to 8, that would be in the first 8 hours. If we want 0 to t, it'd be in the first t hours. The integral from 0 to t of r of t dt gives you total water added. The unit obviously would be in liters, right? If r of t has a unit of liters per hour, the integral of liters per hour would give us just liters. It removes that hour, that per hour. Okay. Here's the other thing we know. We could integrate the rate out, right? The rate out is just simply 5. Integral from 0 to t of 5 dt. Well, if the integral of the rate in gives how much water was added, by the way, look at what I did there. I said 0 to t. I shouldn't say 0 to t because 0 isn't when the rate out starts. The integral from 2 to t, right? I'm going to pretend like I made that mistake on purpose. I didn't, okay? But it's an easy mistake to make. Integral from 2 to t of 5, right? That's our rate out. The integral of the rate out gives us total water drained in liters. Okay. But what I want us to think about here is what if we wanted to know the total amount of water in the tank? Well, we need to consider 3 things. I need to consider what did I start with, how much was added, and how much was drained. Okay, so what I want us to get in the habit of doing is I want to write an amount equation. Okay, and here's what I know. I know I started with 60. I know how to find how much was added by doing the integral of the rate in, and I can figure out how much was drained by the integral of the rate out. So we want to be able to write an equation, okay? And I'm just going to call it A of t for amount. Again, this is an equation for amount of water in tank at time t. Now, asking how much water is in the tank is a very different question than asking how much water was added to the tank. We could have already done that before this video started. How much water is in the tank, okay, we have to consider those 3 things. Right, now this is an initial condition plus problem. So, A of t, again, is our amount of water in the tank. That equals our initial condition of 60. Okay, I get that from here. But I have to add to that 60 to figure out how much is in there. I have to add in how much was added. Well, that would be the integral from 0 to t of r of t dt. Now I got the 60 that was in there, plus I accounted for all the water that was added from 0 to whatever time I want. But then I have to subtract all of the water that was drained, right? So it's initial condition plus integral of rate in, and it's going to be minus integral of rate out. Again, this is where you need to be careful. This is where you need to pay attention to that 2 up here. The rate out integral doesn't start until 2. We don't start draining until 2. And my rate out is simply 5. Okay. So think about this equation here. I can use this equation to find the amount of water in the tank at any time t. Now, if I ask you at a time t before 2, right, we won't consider that, we won't have to worry about that rate out because that doesn't even, we don't even start draining until time 2, right? So if I ask you how much water is in the tank at time 1, it'd be 60 plus the integral from 0 to 1 of r of t dt. I'm not going to do anything with that rate out because it doesn't kick in until time 2. Okay? So here are the types of questions that you might see. We're going to do them today. Why my screen's being so laggy today. So the question is, how much water was added in the first 8 hours? Now, would I use that A of t equation that I just wrote? The answer is no. This is just how much was added, not how much is in there. What's the amount in the tank? This is how much water was added in the first 8 hours. Well, all I have to do here is the integral from 0 to 8 of r of t dt. Now again, these questions usually come up on the free response section, right? And usually they're on the calculator section. So what I'm going to do here is going to show you some tips and tricks to help make this as easy as possible. Okay? The first thing we want to do is correctly enter that function. First off, let me make sure I got to change it to radian. You should always be in radian in AP Calculus. First thing I'm going to do is go to my graph and type in this equation, okay? Now, if you do this right, you only have to type out this equation once. And just make sure that you do so carefully. Because if you make a mistake when you put it in for y1, then it's going to be, every single thing you use it with will be wrong. Okay, so let's clear out what's in there. And I'm going to put in the equation 6 plus 4 sine, I'll use my alpha button, alpha y equals to get my fraction, t squared, again I'm just going to use x squared, over 15. Now it's really important, I just do a double check, look at my function, make sure it matches here, no problems. Okay, and before I hit graph, sometimes these things can take a little while to graph, I want to set my window. Well, my rate in goes from a t value of 0, so that's going to be my x min, to a t value of 8. That's going to be my x max. Okay? Now, I know this graph is 6 plus 4 sine something. Well, I know sine has to be, its values between -1 and 1. So 4 sine is going to have a value between -4 and 4, but it's 6 plus 4 and 6 minus 4. So I know it's only going to live between 2 and 10. So I'm going to put my y min to 0. That rate is never negative. And I'll put my y max to 10. So I just want to hit graph now and take a look at this thing and make sure I can see what's going on. So we can see here's our rate in. That rate is always positive, right? It starts at 6, goes up to 10, drops down to, I don't know, around 2 or so. Okay, so that is our rate in for this setup. Okay. I also want to go ahead and graph my rate out. My rate out is simply the function 5. So I'm just going to graph 5 as well. And again, I can take a look at this thing. And what I see here is for the first part, right, from 0 to maybe around 7 hours or so, my rate in is bigger than my rate out. And again, in your head, kind of mentally, you can think of this part isn't really here because the rate out doesn't start until time 2. But somewhere a little after 7 hours, my rate out becomes bigger than my rate in. And I just want you to think about what would it mean when the rate of water in is greater than the rate of water out? What's going to happen to the water in the tank? Will it be increasing or decreasing? What about over here? It's draining at a rate greater than it's coming in. Well, then my tank overall is going to be decreasing. The volume, the amount of water in the tank is going to be decreasing. Okay. So now watch this really cool trick. Okay. Now, right now I know my rate in is listed in my y1 function. My rate out is listed as my y2 function. So here's what I'm going to do. I'm going to go back to here. I'm going to go up here for a second. First off, let me give myself a little more room to work with. Okay. This rate in, I want to note that that's stored in my calculator as y1. I want to note that my rate out is stored in my calculator as y2. Okay. Watch this trick. You'll love this. Okay. So let's go down and take a look at this integral now. I'm going to do the integral from 0 to 8 of r of t dt. Now, this is a calculator problem, so I want to do this integral on my calculator. But r of t I know is in my calculator as y1. So check this out. I get really excited about it. We can just go back to our graph, our normal screen, and I can type in my integral, math 9, integral 0 to 8. But check this. Instead of typing out 6 plus 4 sine of x squared over 15, I can just use the variable y1. Now the shortcut to get to variables is you hit alpha, trace. See how it gives me this list of variables? Alpha y equals gives me my fraction bar, but alpha trace allows me to pick that y1 out of there, dx, and I never have to type in that terrible equation ever again. I hit enter, and I get my answer of 59 point. You could either have 619 or 620. Remember, it could be rounded or truncated to the third decimal place. Okay, so I'm just going to I'll do the truncated version, 59.619. And again, even if they didn't ask for it, but that would be liters of water added. Okay, so they could ask you how much was added. They could ask you how much was drained. But the next question they're going to ask, or they could ask, is how much water is in the tank at time t equals 8. At the end, how much water do we have? Let's write that out. Okay, so how much water is in the tank at t equals 8? Now, this doesn't say how much was added. It doesn't say how much was subtracted. It wants to know how much is in there. Well, that's where this gets that's where we want to use that equation that we wrote up here. This equation will be able to give us the amount of water in the tank at time t equals 8. Okay. Holy smokes, this thing is laggy. I don't know why it's being so thick. Okay, so let's go ahead and take a look at it. I want the amount in the tank at time t equals 8. Well, that's going to be my initial condition, 60, plus the integral from 0 to 8 of r of t dt minus the integral from 2 to 8 of 5 dt. So again, when we go to our calculator then, we can just type that in. We'll do 60 plus integral rate in from 0 to 8. And again, I don't have to type out that thing again. I can do alpha trace y1 but I have to subtract the rate out. Now, when I do this integral, you just got to check that this rate out didn't start until time t equals 2. All right, so I'll do 2 to 8. Now, you could use y2 because that's stored in there as y2, but even easier is just the function 5. Right? You could use 5 or y2. 5 is less clicks for me, so I'm going to do that. And this tells me that the amount of water in the tank at time t equals 8 is 89.619. And again, or I could say 89.620. Now, if you round it, I'm going to round this one just to be different. Okay, show you that either way is fine. When you round this one, here's where you need to be very careful. Make sure you write the 0. I've talked about this before in class, but you can't just say, oh, it's a 0, I'm just going to drop it and just write 89.62. No. Okay? It has to be 89.620, or it has to be 89.619. Can't be anything else. Okay? Again, our unit here, this is amount of water in the tank, so it'd be in liters. All right. Let's talk about one more thing. Okay. And I'll have another video later for Wednesday with some more questions that they could ask, but this is already getting long, and I'm kind of annoyed that this thing is so laggy. The last question that we'll look at today . Okay, at t equals 5, is the amount of water in the tank increasing or decreasing? Okay. So, to answer this question, right, I want to think of it in a couple of different ways. Right, just think about the context of the problem really quick. Okay. We're filling the tank and we're draining the tank at 2 separate rates. Okay. For the water in the tank to be increasing, which rate would have to be greater? The rate of water coming in or the rate of water going out? Well, if the overall amount of water in the tank is increasing, that means my rate in must be bigger than my rate out. Similarly, if for decreasing, if the amount of water in the tank is decreasing, then my rate in must be less than my rate out. So let's take a look at the graph really quick and just take a look at this, right? I'm thinking about t equals 5. So I'm just going to trace 5. So that's right here, okay? We can see the blue line is my y1, that's my rate in. The red line is my y2, that's my rate out. As we can see, at time t equals 5, the rate in is much greater than the rate out. So we should be able to say that the amount of water in the tank is increasing. Okay, but let's excuse me. Let's think about it in terms of calculus. So amount of water in the tank. I have an equation for the amount of water in the tank. That is A of T. I wrote an equation for it. Okay. To figure out if A is increasing or decreasing, what would I have to look at? Well, I would have to look at A prime. If A prime is greater than 0, if the derivative is positive, that means A is increasing. So the amount of water in the tank is increasing. If A prime is less than 0, then A, the amount of water in the tank, is decreasing. Well, let's find A prime then. Well, again, let's just go back and take a look at our A. How would I do this derivative? Well, again, here's where the fundamental theorem of calculus comes into play. When I do the derivative of 60 is going to be 0, right? That doesn't factor in here because the derivative of a constant is 0. But what about the derivative of an integral? Well, the derivative of an integral gives you the function. They cancel each other out. Okay? So A prime of t would be 0 plus the derivative of the integral of r, which will be r, minus the derivative of the integral of 5, which would be 5. So we get very, very simply here that A prime of t is going to be r of t minus 5. The integrals in front of both of those went away because I did the derivative. And if you think about this, what would A prime of 5 be? I'll just replace all the t's with 5s. It would be r of 5 minus 5. Right, well, I can do that on my calculator. I can get r of 5 simply by tracing that. So when I go to my calculator, I can trace 5 on the blue line, and r of 5 is 9.981, or 9.982. So 9.982 minus 5 is greater than 0. I don't even have to find the number, I just have to know that it's greater than 0. Therefore, here's my justification. The amount of water in the tank is increasing. The amount of water in tank is increasing. Oh, this is funny. It is increasing at t equals 5. That word that didn't come through there was increasing. Okay? So when we write an equation A of t for the amount, A prime always is going to end up being rate in minus rate out. If rate in minus rate out is positive, then the amount is increasing. If rate in minus rate out is negative, the amount of water, or whatever it is decreasing. Okay, I'm going to cut it there. I'll do another video on Monday that's going to help us take a look at some more questions that could be asked. All right, that's it for today. Talk to you later. Choo-chings, bye.